Pre-calculus, logarithms. Two functions are inverses if essentially they undo each other and you swap the x and y. So if this function is y equals 5 to the x power, then you put in the value of x in the exponent, and what you get out is the value of y. In the inverse, x equals 5 to the y, you simply swap this x and y. So 5 to what power is 0.08? Well, 5 to the negative third power. 5 to what power is 0.004? Negative second. Negative first, 0th, 1, 2, 3, simply by the definitions of inverses. If you graph those, you get this graph, which is the reflection about the diagonal of the original. This original is the graph of y equals 5 to the x. This new one is the graph of y equals log base 5 of x. Logarithms answer the question, what power do you raise it to? So here what's being asked is, what power do you raise 5 to get x? We read these y equals log base a of x. And it's simply the same as saying a to the x equals y, only rearranged. So if you have a function 2 to the y equals 32, or an expression 2 to the y equals 32, and you want to change it into logarithmic form, the base becomes this little number here, the result goes here, and then the exponent goes here. So this says log base 2 of 32 equals y. In other words, what power do you raise 2 to get 32? And the answer is y. What power do you raise 2 to get 32? Y. To write in exponential form, the base here is 3, the exponent is 2, and the result is 9. To go the other way, if you have it in exponential form and you want to write it in logarithmic form, the base is 27, the result is 3, the exponent is 1/3. Try the next 4, and I'll write down the answers. This is very simple, but you need to practice it so that you get used to it and you don't go getting it backwards. To evaluate a logarithmic expression, you basically use the definition of a logarithm. So we'll rewrite in exponential form. The question here is, what power do you raise 3 to get 243? Well, 243 is 3 to the 5th. So that means the power is 5. In other words, log base 3 of 243 is 5. Doing the same thing here, we say 10 to the yth power equals 1,000. Well, 1,000 is 10 to the 3rd, so y equals 3. That means log base 10 of 1,000 equals 3. What power do you raise 10 to get 1,000? 3. Solving equations, you go ahead and write it in exponential form. So 8 to the 4/3 equals n. I know that you could put 8 to the 4/3 into your calculator. I would prefer that you not, because I want you to know how to do it if you didn't have your calculator. 8 can be written as a power of another number. 8 is 2 to the 3rd. So what you can do is replace 8 with 2 to the 3rd. By the power of a power property of exponents, you can simply multiply these. 3 times 4/3 is 4. And to simplify that, 2 to the 4th power is 16. So n is 16. Similarly here, we say 27 to the 2/3 is n. 27 is 3 to the third. Multiply your exponents and simplify. N is 9. This radioactive decay problem you will not have to do. There is no problem like this in your homework for this section. But if you wanted to do it, this is how you would do it. When you know how to do logarithms in the calculator, you'll be able to do this in the calculator. You will say log base 1/2 of 1/10 and solve it for t. Right now what you could do is just guess and check. You end up with t is roughly 3.23, and t is the number of half-lives. If the half-life of carbon-14 is 5730 years, to find the number of years, you would multiply by 5,730, and you get roughly 19,000 years.